Hey everybody, my name is Ryan Craig. This is my podcast for the Fundamentals of Physics Section 1 September class with Javier Rivera. My subject is going to be pitch and how it relates to frequency. We're going to be conducting an experiment using a software called Renoise. We're going to look at frequency a little bit differently than we have in class time so far. Usually it's been how many total waves per second, and that's going to be how we define frequency. I'm going to take it more definitionally, as in how many somethings per second, and we're going to look at that by having a sample that doesn't have a pitch, like a drum sample, in a sequencing program like Renoise, and seeing how fast we have to play that to actually produce a pitch, and study all the things that go along with that. So here we are in Renoise. This sequencer might look a little different than what most people are used to. It does run up to down, so just get ready for that. We're going to pick through a few samples here of some snare drums, see what might sound good. These are a little light. This one sounds good. Now we could just take the sample and change the pitch using the keyboard mode here, which is pretty easy to do. Just lower. But we want to actually take a look at how frequency affects it, not just how it works on the keyboard. So we'll enter one of the snare drum in here. Okay, and I'll just put it every 4 here, so we have a steady pattern of these snare drum hits. You can get a feel right off the bat. So, I mean, this sounds pretty cool, but there's still obviously no pitch, so we're going to speed it up a little bit here, fill in the gaps, see what happens. I'm set to 60 beats per minute right now. I've got 30-second notes going. So, all right. Sounding closer to a machine gun. Still no pitch, so we're gonna go up the tempo here and see if we can make some adjustments ourselves. You should definitely be hearing something now. And that was fun. We hit 999, which is the max. So let's play around here and fill in all the gaps, see how high it gets. That's cool. It actually sounds like it's a full octave above the note we just got. So recap, we know that when the beats per minute rose, the frequency also rose. And that's because the space in between each snare hit became smaller as the speed of the song went up. When we first started, we were at 60 beats per minute, and when we got to the end, we were at 999. At 60 beats per minute, the frequency is only 16 hits per second, which is, if we were dealing with smooth sine waves, it'd be below human hearing range. But once we got to 999 beats per minute, we reached 266.4 hits per second, approximately, which puts us just above middle C on the piano keyboard. I think that's really cool, considering you could have just about any sound in the world, like a snap or me hitting, pen on the desk. If you do it fast enough, it would actually sound like something coming out of some sort of instrument, or like a synthesizer. So yeah, that's the conclusion. We know that speed, relative to how many times you're hitting it in a second, more equals higher pitch for our ears. If you want to check out Renoise online, it is www.renoise.com. And I believe that is all my references. Thank you.